All right, let's take a look at the second question. We have triangle ABC, and it's given that angle A is 90 degrees, so that means that this down here is angle A, and this is going to be side A. And we're also told that side A is 8.2 centimeters, and we're told that side C is 6.0. So we have to label A and B onto our diagram. I'm going to put B down here, and I'll put C up here. And if B is down here, then this is side B, and this is side C. And we're given information about side C, so I'm going to put 6.0 centimeters here. I'm just going to clean up our diagram a little bit and get rid of our A, B, and C sides. For this question, we're asked to solve triangle ABC. And that means that they want us to figure out all of the unknowns. They want us to figure out what this angle is over here. They want us to figure out what this angle is over here. And they also want us to figure out what side B is, or the x is in this case. We could figure out x by using the Pythagorean theorem, but I want to go through this problem using trigonometry all the way. So to be able to use trigonometry all the way, the first thing we need to do is calculate either angle C or angle B. And I think what I'm going to do is I'm going to calculate angle C. So let me just again clean up our diagram a little bit right here. What I'm going to do is I'm going to label angle C as theta. Now that I have a focus angle, I can label the sides with adjacent, hypotenuse, and opposite. Opposite the angle that we're focused on is the opposite side, and opposite the 90 is the hypotenuse, and that makes this the adjacent when we're focused on angle C. Because we're given information about the hypotenuse and the opposite side going back to our trig functions, we are going to use the sine function. So let's write that down. We're going to have sine of theta equals opposite over hypotenuse. We don't know what theta is. That's what we're actually trying to calculate. We do know that the opposite side is 6 centimeters and the hypotenuse is 8.2. So now we can actually calculate this, but we have to first move the sine away from the theta. We end up getting theta equals sine inverse of 6.0 divided by 8.2. Now again, you can calculate this first, or you can do it all in one step. So let me pull up my calculator, move it out of the way so you can actually see what we're doing here. I'm going to type in 6.0 divided by 8.2 and hit equals. And now I'm going to use my sine inverse function. So I have to go on to the trig drop down, second function, and then sine inverse. And now I know that angle theta is 47.0 degrees. So we know that this angle up here is 47 degrees. Now, all those angles inside of that triangle have to add up to 180. That has to equal the 90-degree angle, the 47, and the measure of angle B. Doing some quick math in my head, I can see that angle B has to be 43. All right, so now we know the two angles. The only thing that is left for us to do is calculate x. And again, I said you could do it with the Pythagorean theorem, but let's use trigonometry to calculate the length of side B. And in this case, the focus angle I'm going to use is angle B. That means I have to relabel my diagram. This is going to become the opposite, this is going to become the adjacent, and hypotenuse always stays over here. We're looking for x, which is the opposite, and we know information about both the hypotenuse and the adjacent, so we can use either one of them. And in this case, I think what I'm going to do is I'm going to use the adjacent. So I need a trig ratio that combines opposite and adjacent, and that's my tan ratio. So let's start off by writing down the formula. So tan of theta is going to equal opposite over adjacent. I'm going to plug in what I know. I know that angle theta is 43 degrees, and I know that opposite is what I'm looking for, and adjacent in this case is 6.0. I'm going to move the 6 over to the far side by multiplying both sides by 6, so I end up getting 6 times tan of 34 is going to equal x, and then I'm going to pull my calculator up. I'm going to start by figuring out tan of 43. So I go 4, 3, drop down tan, and now I'm going to multiply by 6. And I get 5.595. So I'm going to round that to 5.6. So side B, represented by x in this case, is going to be 5.6. So now we have solved our triangle. We know that this side over here is 5.6. and we know everything else. So this triangle is looking a little bit messy, but let's redraw it and label it nicely. So we have our 90-degree angle here. This is going to be C, this is A, and this is B. writing in the information that we've calculated, we know that this is 47 up here, this is 43 down here. We were given that this was 8.2. We were also given that this was 6.0, and we calculated that this is 5.6. And just for fun, if you like, let's use the Pythagorean theorem and see whether or not our side lengths are correct. The Pythagorean theorem says that a squared plus b squared is going to equal c squared, and remember that c is always the hypotenuse. So the hypotenuse is over here, a and b, it doesn't really matter, but this has to be c. So we're going to end up getting 5.6 squared plus 6.0 squared should equal 8.2 squared. Pulling up my calculator, I get 5.6 squared plus 6.0 squared equals, on my left side of the equation I get 67.36, and on the other side of the equation I get 8.2 squared, and we get 67.24. Not exactly right, but there is a little bit of rounding involved here. If we would have kept more significant digits in our answers would be more accurate.